Hi, this is Colleen Quinlan. I'm recording for Project 2 for Introduction to Machine Learning. Just showing here we have the type of nearest neighbor is configurable. I'm going to set it to regular nearest neighbor, and I'm going to go ahead and run the data. I am periodically pausing just because the regression data sets take a bit longer, but I want to show that it is updating live. So you can see that it started the abalone regression data, and it will start to update in a second, and then I will pause again. So you can see here it started to update. I'm going to pause until it finishes. Okay, so we have the finished results, which I'm going to show quickly. For the card data evaluation, which is a classification task, you see high percentages or high accuracy percentages above 0.7. For cancer data evaluation, we see in the 80s and 90 percentages and 100% for the fourth split, which is pretty impressive. The average was 0.944. For voting data, you see again in the 80s and 90s, average 0.857. And then for the abalone data, we see mean squared errors of 6 and 7 and a 5. For forest fire data, 6, 5, 6, 8, 10 with a mean of 7. And machine data evaluation has a mean squared error of 3, 4, 2.5, 4.705, 2.969, and 3.699 as the mean. You see here, this is the cross-validation which is performed. The data is split into buckets of 20% and 80%, and then you can see those folds in the results, and that K is set to 5, so you get 0 through 4 different results here. And then for the neighbors, K is also set to 5. So I've added a printout so that you can see my actual distance function calculation. So here you're seeing the distance is being calculated. So what's being printed is the DFK shortest. And so it's taking the sum column, which is the distances, and that sum column is going to be the 5 smallest. So you can see that consistently the smallest distance for this data set is between 1 and 2. It shows them in ascending order because that's what the n-smallest function does. And it does this for every data set after calculating the Euclidean distance here. Euclidean distance is the data, the training data minus the test data point squared, and then you sum those up and take the square root, and that leaves you with these 5 neighbors for K equals 5. I've commented out the classification data sets, and now I'm printing the Gaussian kernel, so I'm gonna run that. This will take a bit longer, so I'm gonna pause it. Well, actually, so you can see here the kernel's getting calculated. I'm gonna go ahead and stop it just for sanity's sake. The error is from stopping it. So you can see here, these are the kernels getting calculated. It's being done here. I take the distance from the Euclidean classification. I take the training class. I set it equal to that row. I then take the norm from the vector, the distance vector. I square it. It's negative. I divide it by 2 times sigma squared. The kernel weighted is the sum of those values and the times the training class classification, and then the kernel unweighted is the sum of just the unweighted kernel. And then sigma is supposed to be tuned, but I did not tune it for this.